So the chain rule. Also known, at least to me, as the Tootsie Roll Pop rule. And again, my hope is that you'll remember this the whole year long, especially with this up here, because the chain rule happens on every test. It's not like explicitly tested, but you have to use it. It's like a foundation to, it'd be like in second grade, if a kid asks, or first grade, whenever they learn how to add, like, when are we going to use adding? You're like, well, the rest of your math life you're going to use adding. It's almost the same with the chain rule and calculus. When are we going to use this? Well, it's going to become so second nature that you're going to use it the whole year long. So it's important to have something to tie to it, and maybe that'll help you remember, especially on test day. I'll usually remind you to, hey, remember the Tootsie Roll Pop, because that's a common mistake, is to, because we're going to move forward, we're going to do other stuff, and this is just going to be going on in the background, and the mistake is people remember the new stuff, but they'll forget the process of the chain rule or the Tootsie Roll Pop. All right, I happen to take note of each person eating their Tootsie Roll Pop, and I noticed a consistent theme of how you did it. The very first thing you did, somebody tell me, what did you do first? Go with the simple answer here. This isn't complicated. You took the wrapper off. Yeah, good work. So with the chain rule, you got to work from the outside in. Right? Nobody put the whole thing in their mouth, wrapper and all, and just took a bite and started chewing. Previous years, I taught this lesson, and I said this first before I gave the Tootsie Roll Pops. And so someone to prove me wrong last year put the whole thing in his mouth, wrapper and all, bit down on it, and just started chewing it. Like, I don't know what that does for his teeth. That was gross. He ate the wrapper and all. Like, that's not how you eat a Tootsie Roll Pop, and it's definitely not how you do the chain roll. Okay, and I'll show you what I mean by that later. I'll show you a common mistake that is the equivalent of just sticking the whole thing in your mouth and eating it all at once. So work from the outside in, and if you don't want to break your teeth anyway, you got to go one layer at a time. All right, you're a few minutes into the Tootsie Roll Pop. Nobody is to the Tootsie Roll yet, because you're still working on the hard candy layer. Took the wrapper off, working on the hard candy. Eventually you'll get to the Tootsie Roll. Eventually you'll get to the stick. I don't know, this may be overkill to write this down, but you start with the wrapper, then comes the hard candy, then comes the Tootsie Roll, and then you get to the stick, and you're done at that point. I know you're still thinking, okay, yes, that's how I eat a Tootsie Roll. Good work. Why are we talking about this? Because it's also how you take a derivative of something that is multi-layered. The other way to do this lesson is with an onion, but nobody wants to snack on an onion one layer at a time. But it's the same idea of one piece at a time, one layer at a time. All right, here comes the calculus, but the calculus of this is probably not going to make much sense until we do some examples, and it's probably only going to make sense in terms of Tootsie Rolls, not in terms of what I'm about to write. So the derivative of f of g of x. So when we have nested functions, functions within functions, like the sine of x cubed, or the log of the tangent of x squared, like that would be multi-layered, but they'd still work the same way. So let's see if we can make sense of this and tie the calculus to the Tootsie Roll. So the wrapper, the outside layer, the most outside layer is that f. So the first thing we would do is unwrap or take the derivative of the f. When we do that, we don't mess with the inside. All right, when you took the wrapper off, that's the only thing you did. You didn't eat it all at once. You don't crunch everything at one time. One piece at a time. If we stop there, though, that would be the equivalent of taking the wrapper off and just putting it down. And that's not how you eat a Tootsie Roll Pop either. We want to keep going and get the rest of the way. The rest of the way is what's on the inside. So then we would take the derivative, or take care of, the inside stuff. And some students get confused. They want to say, well, how about the derivative of what's on the inside of that? And you can, but what's the derivative of x? Yes, I want to use like 1, I think. Yeah, derivative of x is 1. So then you're down to the stick, and then you're done. So we don't usually put times 1, but if you really wanted to kind of follow the analogy all the way out, I guess you could chain rule it all the way down to 1. Okay, probably still confused as to what the heck is going on. So let's do some examples, and I think that'll help us make sense of the chain rule. X squared plus 1 to the 1/2. So there's multiple things going on here. There's multiple layers to this problem. I've got an outer layer and an inner layer. So there's lots going on, but I can only do one thing at a time. So I got something to the 1/2. That's a power rule situation. So I'm not going to worry about the inside just yet. I'm going to take care of the power rule. That's sort of my wrapper for this problem, because it's the outermost thing. So I'm going to take care of it first. We know how to take care of power rules. So that's 1/2 times whatever's on the inside to the negative 1/2. And we're going to fill in the blank, but I'm intentionally leaving it blank because that stuff stays the same. When we take care of the wrapper, we do one thing at a time. We leave the inside stuff alone. But we're not done yet, because all we've done is take the wrapper off. We want to eat this Tootsie Roll Pop. So I need to multiply by the derivative of what's on the inside. So derivative of x squared plus 1. Again, now I'm not worried about the wrapper. I took care of it. I'm only looking at the inside now. So that would be 2x. So you got to handle all the derivatives, but you handle them one at a time from the outside in. And whoa, I should have put a prime on that, because that's a derivative.
Why is the exponent negative 1/2?
Because the power rule is bring the exponent down front as the coefficient and decrease the power by 1. Now, as always, there's some cleanup work to do. That would be a safe stop. But usually, if we were asking a question, a simple, straightforward question, it's going to be on the multiple choice part, and that's going to force you to do some algebra. 2x over 2. The 2's would cancel. That x would be on top. This stuff would be in the bottom. So like that. And I guess if you wanted to get fancy, you could write that as a square root down there. Let's do another one. Let's say y equals cosine of x cubed. So again, multiple things going on here. A cube and a cosine. But what's the outer layer? What's the wrapper? The cubed, not the cosine. The cosine's on the inside. So this time, again, whatever's on the outermost is the wrapper. That's kind of where we'll start. I'm going to write this one as dy dx just to put the different format of calling something a derivative, just to keep that in front of you so we don't forget that option. You just as easily could have put y prime. So the wrapper is the cube. I know how to handle a cube. That's the power rule. So I'm not worried about the inside, right? One layer at a time, one thing at a time. 3 times the inside squared. That's the power rule. I always hesitate to give the wrong answer because some people are going to hear it wrong. But the common mistake is to crunch your Tootsie Roll Pop all at once and to put negative sign in there. But that's handling everything at one time. We don't want to do that. One layer at a time. So let's leave cosine x alone while we're taking the wrapper off. But we need to keep going. We're not done. So we've handled the outside stuff. Now we need to go to the inside stuff. And the derivative of cosine is negative sine. Yeah, that's why that was the reason Taylor Swift killed Justin Bieber right there. And I guess there's really not a whole lot to clean up on that one. Move the negative sign out front. That's about it. You can put the squared on top of or in the cosine like that. Just a reminder that those mean the same thing. And again, the difference between a free response answer and a multiple choice answer. Although that one wouldn't be easy. If you got that and then you started looking for answers, you'd make that connection really quick. I hope. All right, example 3. This one's going to look really similar to example 2. Y equals the cosine of x cubed. So example 2, let's make sure we understand the difference between the two. The cosine of x cubed versus the cosine of x cubed. And I don't have to write parentheses on that. It would sure be helpful if I did, but it's not absolutely necessary. And I don't know if the book would or wouldn't. They wouldn't have to. If it was anything more than that, they would. We can see if they do that. They don't, if it's just like that. They don't. So I'll leave it, because that's the cosine of x cubed, even though I don't have parentheses written down there. So what's the outermost thing? What's the outermost layer, the outermost wrapper for example 3? It becomes a little easier if you do put the parentheses on there. What's the outermost thing now? The cosine. So the outermost thing is the cosine. So I'm not worried about x cubed yet. Let's go one piece at a time, one layer at a time. So derivative of cosine is negative sine. Again, don't derivatize. Don't derive it all in one place. Don't crunch it all at once. Leave that x cubed alone, because you can only do one thing at a time. Now we can handle the inside. Derivative of x cubed would be 3x squared. So not a lot of cleanup on this one. Probably move the 3x squared to the front. Like that. So I'm trying to leave 2 and 3 on the screen at the same time. So you see that they're both the cosine of x cubed. I mean, if you just say it kind of all quickly, you don't know which one it is. You need to see that it's the cube of the cosine versus cubing x and then taking the cosine. And because they're different functions, obviously you get different answers for the derivative. All right, so you feel okay with the connection between the Tootsie Roll Pops and chain rule? I saw 2 heads nodding, so we'll go with that. Let's do one more. We start to put pieces together here. So h of x equals x squared plus 1 times the sine of 4x cubed. What rule is this going to require? Chain rule here, but what other rule is this going to require? What other rule is this going to require? Product rule. So I'm going to have to set this up as a product rule problem, but I'm also going to have to do the chain rule sort of within the product rule. So this would be a good place to not try to do the product rule in place. This would be a good one, even if think you're to the point where you can do the product rule in place. Because of the complications of this one, I would write this one out to keep things straight. So f prime, let's put some people on the spot here. We've done enough of these. Dawson, I love when I say I'm going to put people on the spot. All the heads go down. Don't look at me. I'm not making eye contact. He still won't call on me. Dawson, if f is x squared plus 1, what's the derivative of just of f? I don't want anything else.
2x plus 1?
Ah, so close.
2x.
2x, good. Just 2x. Because the derivative of a constant is 0. And in some ways I'm glad you made that mistake, because that's a super common mistake is, months down the line when we're doing these really complicated derivatives and you've got all these rules and you're keeping track of everything, you forget that the derivative of 1 is 0. It's frustrating. All right, for the derivative of g, I've got a Tootsie Roll Pop situation here. I've got an outer and an inner thing going on. So, Josh, what's the outermost thing? What's the wrapper that I have to consider first for G?
12x squared.
So that's like the innermost thing you just did.
Cosine.
Yeah.
And that would be cosine.
So cosine. Let me really put you on the spot. The cosine of what?
Cosine of x.
When you take the wrapper off, what are you doing with the inside of your Tootsie Roll Pop?
Oh, you leave it.
You leave it. So 4x cubed. And then you already gave me the next thing, so you kind of jumped ahead a little bit, and it would be 12x squared. But that's the innermost part. And so those are, I'm glad I called on people, because those are some of the mistakes people make, because they get things a little out of order. They try to crunch it all at once. Work from the outside in, one layer at a time. And I still got to finish this problem. So where was I? Product rule. So back up, big picture, I was doing a product rule. So that's first times derivative of the second. This is going to be a mess. First times the derivative of the second. I'm going to put the 12x squared in front and then the cosine. Plus the other way around, the second times the derivative of the first, and again I'm going to put 2x in front because it just looks better there. That's a free response answer, and I don't know that there's anything you could do to clean that up. My guess is CalcChat in the book, they really like to do as much algebra extras as they can. My guess is they would factor out a 2x, but this is also one where if you made it to this free response answer, I think you would recognize the multiple choice answer. So again, just be careful. So as you're working problems, check them in the back of the book, because the test, a chunk of it is multiple choice, and so if you make it this far, you need to be able to make it to the next step to match things up. The test, by the way, is about half and half free response and multiple choice. We do that because the AP test is half and half free response and multiple choice. Page 136, 7 through 33 odd, and 65 to 69 odd.